Alright guys, welcome to our channel Code with Sunny, and today we'll be discussing the fourth problem of this bi-weekly contest 71, that is minimum difference in sums after removal of elements. That is this one. Its index is 2163. So let's begin. Okay, so this is the hard problem of this lead code, and yeah, like if the let me talk about the first prerequisites required to solve this problem. So the like you must have good knowledge of how to use a min heap and max heap like priority queue. You can also use a multi-set type of thing, but yes, you need to know how to find out the first k smallest elements and first k greatest elements in an array at any time. Okay, like when you're iterating from the array from left hand side, and you need to like if anyone asks you what is the first k smallest sum of elements up to this position, then you need to know the efficient way. If you doesn't know that, no need to worry about. So this is the video where I'm going to explain the entire thing. Okay, from the like from every possible case, like from the base. Okay, so also you need to know how this like we are also using the greedy approach to perform the operations. And yes, the main thing is you need to know how to use min heap and max heap to find out first k smallest and k greatest elements in this array at any time. Okay, so you are given a zero indexed integer array nouns consisting of 3 n elements. Okay, so the size of the array must be a multiple of 3, and we are allowed to remove any subsequence of elements of size exactly n from nouns. So yeah, okay, we are going to remove any n elements, and that n elements will be subsequence of this original array, and the remaining 2n elements will be divided into two equal parts, the first n elements belonging to the first part and their sum is this sum first, right, and the next n elements will be have the sum second, and the difference in sums of the two parts is denoted by sum first minus sum second. Okay, so if sum first is this one. Okay, so I will discuss all those, so no need to worry about. Return the minimum difference possible between the sums of the two parts after removal of n elements. Okay, so let's pick out this example and let's try to understand what does this problem is going to signify. So 795813. So let me just erase this entire thing. This was actually for the third problem that I've discussed recently. Okay, so it is, you can erase it directly also. Okay, so 795 and 8, okay, 813. Okay, you can see n, which is the length of this array, is actually 6 and it is a multiple of 3. So we need to remove exactly n by 3, which is actually 2 elements from this array, and then we will divide. Let's suppose we have removed this 9 and we have removed this 1. So my remaining array would be 7, 5, 8 and 3. So first n elements, which is you can see 2, first 2 elements will have sum as sum f, sum first, and the next 2 elements will have sum second. So sum f will be actually 12, sum coming out, and sum s is actually 11. So you need to find out the difference between sum of and sum s, which is actually 12 minus 11. So you are going to get 1. So this is the one of the possible way to do the operations. You can see I have removed 9 and 1. You can also remove what? You can also remove 9 and 5. You can also remove 7 and 8. You can also remove 5 and 3. There are many possible ways, and like to choose this one is going to be like hectic task, because n at max goes to what, 10 raised to the power 5. So this, when you have 10 raised to the power 5 3, it will have some value, let's say x. So choosing x elements from this one would be like ncx, and when you are going to do this, and then we have the remaining array, and then you will find this divide this array into two parts, and then you will get the sum. So ncx amount of time will be, like you can see, this is actually the binomial type of thing, ncx, which is actually n factorial upon x factorial n minus x factorial. So choosing the numbers x elements from this n size array, and it will take this amount of time, and this is actually very much used because n is actually used. So this brute force will not work, so we need to find an efficient way. Okay, so how we are going to do that? So consider the case like just forget about this thing like removing any subsequence. Okay, so just forget this one. So just consider the case like you need to choose first n elements. Note that here n is actually n by 3. So you need to choose first, like you need to choose any n elements, and again you need to choose any n elements for this right case. So this is actually sum f and this is actually sum s. So when you are able to choose any n elements, and like first we are able to choose for any prefix, you are going to choose any n elements, and then all these n elements will lie to the right hand side of these elements. Okay, so it will be like sum s. When you are able to do that, the remaining elements is actually n minus n plus n will automatically will get removed. We are not interested in that. Okay, so just consider choosing any n elements from this entire array, and let the sum denoted by this is sum f. Okay, and when you are able to do that, all the elements which lie in sum s will be to the right hand side of this sum f, and yeah, right hand side of this array, and the sum is going to be denoted by sum s. If you are able to do that, the remaining elements will always will not be considered, and it will be considered as removing these elements from the array. Okay, now let's try to understand this equation. Equation is actually nothing but a simple thing, sum f minus sum s. Okay, so yes, so you need to minimize that. So you need to minimize that, then you can say that yes, you need to make this as maximum possible and make this as minimum possible. No, I have said something wrong. You need to make this as minimum possible. Like I said, the reverse thing, this as minimum possible. Let me write as minimum possible, and you need to make this as maximum possible. Can you understand why I'm saying this one? Yes, you can understand. I will consider you guys as like a math guy. You can understand this one. So when you try to make this sum f as minimum as possible, so this sum will decrease and this sum will increase, this value will increase. So when you will find the difference, sum f minus sum s, this will be the minimum. So consider the case like you have 5 and 9. So difference will come out to be 5 minus 9 will 4. When you try to make this as minimum, let's say you have 3 and 9, you can see the difference is coming out to be, previously it was minus 4 and it will come out to be minus 6. You can see you are getting minimum with respect to this minus 4, like less value. So you will make this sum f as minimum as possible and sum s is as maximum as possible. Okay, so then only you can have your answer being minimized. How to do that? Okay, so there is one more thing that you must take care, that when you have these n numbers, suppose you have these n numbers, let's say 9, 5. Okay, and then only you are going to choose all those numbers which are right to this 5. That is, first you will have these all numbers for any prefix, then you will have, let's say you are going to choose 8, 1. Okay, so you can see these 7 and 3 are automatically eliminated. Okay, so when you are trying to focus upon that, finding this sum f which is choosing n elements, and these n elements will have sum as minimum as possible. So what is the best way to do that? To choose only the minimum elements for any prefix. Okay, so if you're not getting it, no need to worry about. Suppose you are at this prefix 795 and you need to choose n elements such that their sum is minimum. So you have the choice as 795, so you will choose only the minimum elements 5 and 7. Okay, in that case your sum is coming out to be 12. If you choose 9 and 7, your sum will come out to be 13. If you choose 9 and 5, your sum will come out to be 14. Oh sorry, if you choose 9 and 7, your sum will come out to be 16, right? If you will choose 9 and 5, your sum will come out to be 14, which will be the maximum, but you need to choose as minimum as possible. So you will choose 5 and 7. You can see actually if you sort this array 5, 7, 9, the 5, 7 are the first two minimum elements. That is, you need to choose first n minimum elements up to the current prefix. And similarly, for case like sum s, you need to choose as maximum as possible. So if you're considering this prefix 795 for this prefix, then automatically the remaining ones would be like you need to consider n maximum elements from this suffix. 813. Okay, so in that case, if you sort this array 813, you will get 1, 3 and 8, and you need to choose first, you need to maximize the sum, so you will choose the maximum elements 8 and 3, so it will come out to be 11. Okay, and the minimum is coming out to be 12. Okay, so if you find out the difference, you will say 12 minus 11 is coming out to be 1. So in that case, you are going to minimize this equation, right? So yes, so now again the same thing. How do, like, there are many possibilities now. So what we are going to do is we are going to consider every prefix. So let me move on to the next page because it will make everything so shattered. So consider every prefix. Consider every prefix, and for each, okay, so prefix, it should be prefix, and for each prefix, find the minimum sum. Let me write down minimum sum. For each prefix, find the minimum sum of first n elements considered up to this current position, first n elements. And if you are at this, let's say 0 to I, if you are at this one, then the next suffix should be from I plus 1 to the n minus 1. So this will be automatically the suffix, and you need to know the what is the first what is the maximum sum for this suffix. Okay, so you need to know the maximum sum for this prefix. So in that case, you will do sum f, like this should be minimum up to the first I minus sum s actually. So you will minimize your sum for every prefix, like your I is going to vary from 0 to n minus 1. So this is actually the capital N, this is the entire array. Okay, so how do we calculate the sum for each prefix? Okay, so this is actually the famous thing that you need to know, like first, how do we search for that? Kth largest element in an array, I think, yeah, kth largest element in an array. Okay, so if you're not aware about that, then you can understand, you can read out this article. So if there is a problem over the Leetcode also, if I'm not wrong, it's kth largest element in an array, Leetcode. If you are able to do that, then you can have a basic idea of this one also. I think I must have also done that. Yes. Okay, so if you're at the current prefix, let me give out a small idea. Like suppose you are let me say I have the elements as 795 and 813. Okay, so let me do some calculations and show you guys how it is going to be done. 795 and 813. So you will be having a prefix array and you will be having a suffix array. Okay, so I will maintain a heap to find out the sum of first n elements for every prefix, and that would be going to be minimum, and for every suffix first n elements, and it is going to be the maximum sum for at every index. Okay, so let us build out the prefix one. So let me just make a 6 size array, 1 2 3 4 5 and 6. So we'll be filling the elements. Okay, so note that I'm talking about the prefix one. Okay, so you need to choose, like capital N is 6 and n will be 6 by 3, which is actually 2. Okay, for every index we are going to fill up that. So consider only 7. So there doesn't exist only, like there exists only one element and still we haven't reached the 2. So yeah, we will be considering only 7. Now the next is 9. So you will consider 9. Okay, so for here you will say you will fill up some value, let's say int max. Like there doesn't exist any, like you cannot choose small n equal to 2 amount of elements. Okay, so when you consider 7 and 9, you can see yes, you can choose 2 elements. So what is the minimum sum you can get? So 9 plus 7 is 16. Okay, so now when you consider 795, this one, so when you consider 795, you would have this one 795, but you need to choose only 2 elements. So in that case you will pop out this 9 because this is the maximum element. So this is the basic criteria of finding the kth largest element in the array or the sum. Okay, so when you are considering 795, you can see 795, but you need to choose only 2 elements, right, for this entire prefix. So you will Wait a minute, there is something called. Okay, so let me take this letter out. Okay, so yes, so 795. So you need to choose two elements. So what we will do is like we will neglect the maximum element. If you neglect the maximum element, so you will have only 75. So for at this position 795, the minimum sum that you can get there by choosing only two elements would be 7 plus 5 12. Okay, now the next element is 8. So when you consider the element 8, again you need to choose only two elements. So these all elements are in the heap, but you need to choose only two elements. So you will pop out the maximum element because we need to find out the minimum one, right? So you will neglect this 8, again 7 5 12. Okay, now again the element is 1, that you are considering this entire thing 7 9 5 8 1. Okay, so you have 7 5 and 1. When you push out this one, you can see you need to consider only two elements, so you will neglect this maximum element which is present right now. So the remaining is 5 and 1, so it is coming out to be 6. Now again you need to consider this entire thing 7 9 5 8 1 3. So you have the current elements in the heap as 5 1. When you insert this 3, you can see the size is going to be greater than 2, so you need to extract the maximum element which is 5, so you will neglect 5, and here you have 1 and 3, so it will come out to be 4. Okay, so what we have actually in this prefix array, so at every position, like if you're talking about this position, so we have considered the first four elements 7 9 5 8, and we have the sum to, like the minimum sum to choose two elements among this 7 9 5 8. You can see it is actually yeah 1 2 3 and 4. Yeah, so you can actually you can choose 7 and 5, which is actually 12. Okay, and if you consider up to this one, you would have the element 7 9 5 8 1. So in that case you can choose the two minimum elements to find out the minimum sum 5 and 1, which is actually 6. So this is for every prefix. So similarly you can build up for every suffix also. So yeah, so let me denote it for the suffix. Once you can fill up it again, it doesn't matter. So for every suffix you will be having again a 6 size vector. Okay, so let me fill up now fastly how we are going to do that. So yeah, so again we have 3, so we have only one element. So what I am going to do is like, yeah, we cannot choose two elements, so let me fill up int max. Now we have 3 and 1, so you can see there is only two elements. Yes, we can, no choice, so we have 4. Now we have 8 1 3. Okay, when we have 8 1 3, you need to find out the maximum sum. So you will neglect the minimum one, which is 1. So the sum is now 8 and 3, which is 11. Again, now we have 5 8 1 3. So you will push 5 8 3 and 5. So but yes, you need to choose two elements, and that sum would be maximum. So you would take 8 and 5, and this is the minimum 3. So we will neglect that. So 8 and 5 is actually 13. So now again you have 9, so you would have 8 5, the elements right here in the heap, and you have the 9. Now you need to consider the two elements which are maximum, so you will neglect 5. So 9 and 8 is 17, and you have again this 7, so 8 9 and this 7. You need to choose two elements which are maximum, so you will neglect the minimum, so 7 will be neglected, so 9 8 is 17 again. Okay, so there will have prefix array and there will have suffix array. Now you will consider every prefix. Suppose you have considered only these two prefixes. Okay, so you need to choose the two elements from this one, and which has the minimum sum. So you will have the pref of I, which is choosing two elements and having there as minimum sum. And for this suffix, you can see you need to choose two elements which have maximum sum, and sum f minus sum s, which is sum of I plus 1. This will be your current answer. So you need to minimize that. Answer equals min of, like you need to find min of pref of I minus sum of I plus 1 for every I belongs to 0 to n minus 2. You need to find this minimum value and just return the answer. This is actually your answer. Okay, so let us move on to the coding part, how we are going to do that. You can see I have done in one shot. Yeah, this is actually the easy problem, I think. Yes, but yes, I'm not going to demotivate you. Yes, because yes, you need to have a good practice over that. So yes, I've defined ll as long long and inf as long long max. Okay, So sum first minus sum second should be minimized. So sum first should be as min as possible and sum second should be as maximum as possible. N is actual num size and capital N will be n by 3. So first I will build up this prefix and suffix array. So prefix is going to sum of first n minimum elements from the left side and sum of I will be sum first n maximum elements from the right side up to the current index. So we will have sum as 0 and we will have priority queue. You can see this is actually the max heap. Okay, now when you build up the prefix, at each time if the priority queue size is going to be strictly greater than this capital N, so in that case you need to extract out the maximum element and that maximum element will be always present at the top of the priority queue, right? So I'm going to do the same, find out the sum, like increment the sum and push the element in the priority queue. And if the size of this priority queue is going to be strictly greater than n, so you need to pop out the maximum element and that maximum element is going to be present at the top of the priority queue. Okay, so you will decrement the sum and pop out the element from the priority queue. Again, you can see if the priority queue size is exactly capital N, that is, it means that you can choose the elements, you can choose n by 3 elements. Okay, in that case I will write prefix is exactly equal to sum. Suppose this condition doesn't become valid, in that case pref will have the default value which is inf. Now again sum as 0 and we will clear the elements in this priority queue. Now again we will build up for the suffix, that is from n minus 1. Now again you are going to using like I am using the same heap. Okay, now it is actually the max heap, but at any position you need to you need to find out this you need to consider the first n by 3 maximum elements. So if the size of the priority queue exceeds the capital N value, in that case you need to extract the minimum element, right? And that minimum element is also going to contain on the top of the priority queue, that is the max heap, only and only when we are going to push out the negative values of the elements. So this is quite tricky, but like if you are not going to able to understand, you can use another heap and that heap is going to be like min heap. Okay, you can do that, but I'm not using that. In spite of that, I am going to push out the negative value. In that case, you can see priority queue automatically by default becomes the min heap because we are pushing the negative elements. Okay, so when the size is again greater than, pop out the minimum element. Now you can see I'm adding the sum because it is actually containing the negative value. Okay, so it doesn't matter. So yeah, q dot pop, and if size becomes same, so for phi is actually equal to sum. Now we need to minimize the answer for every prefix. So I iterate for this 0 to n minus 1. So if my prefix is not inf, yes, we can choose. Suffix is not inf, like I plus 1, then we can choose. Then find out the minimum answer and return this answer. So this will give you all test cases passed. So if you guys have still any doubts, do reach out to us in the comment section of the video. And thank you for watching this video.